I am driving through the mountains here. Beautiful, beautiful drive. I was driving most of the night last night through the darkness. But this isn't about the drive. This is about where we're headed. This is my van, and it's a bit basic, bare bones, and I need to build it into a mobile podcasting, storytelling, video studio. Instead of just buying all the components and making mistakes and trying to figure it all out, I have decided that I'm going to go around North America and meet with the industry leaders in each category of building out a van for off-grid living. And we are on our way to meet with they're called ambassadors at Victron, but he's an ambassador of Victron Energy, a company that makes basically the backbone of your electrical system in these sort of projects. They do the inverters and the switches and the DC to DC controllers and the monitors, and they work together to create the system from which you add batteries, you add alternators, you add solar panels, you add components, and you power components. Very, very important. And I called Victron a while ago and I said I'd like to work with you guys, and I'd like to have you guys work with me. And so the call went really well, and now I'm on my way to meet with one of the ambassadors in North America, and his name is Caza, and he's building a van out in Philadelphia. So I've been driving about 2,200 miles to his location, and I am about 100 miles away. So I'll meet him while he's finishing his build out. So I'm excited. Onward. Howdy.
What's up, buddy?
Oh, this is a beautiful area. Holy moly.
It is, isn't it?
Yeah, I'm like driving through, I'm like, who needs an overland vehicle? You're basically living out here.
The rolling hills, yeah, it's nice.
How's it going?
Good to meet you.
Good to meet you too.
So this is my client's property here.
Okay.
This is his rig. This is my van. And we're outfitting them with 1,400 watts of solar and 400 amp hours at 24 volts, so he can run his AC and fridge and everything else he wants. So this is the fridge, this is the back of the fridge, and we took the wires in from the solar up here. You can see them right over here. So my business is RV Solar Connections.
Yep.
I started that last year, and so I do it full time now.
Nice. Yeah,
Yeah.
business is probably pretty good these days.
We got everything turned off right now.
Okay.
But we wanted to keep it inside the dinette.
Yeah.
You know, we didn't want to lose any storage if at all possible.
So these are the batteries? No. Yeah, okay.
Yeah, these are the batteries.
Okay.
And the Lynx system, you know, the bus bars and the shunt, that's all going to mount on the wall.
Okay.
Right there. And then this is where pretty much everything else is going to be.
Okay. I'm looking at like spacing too, you know, I'm looking at the van. You'll take a look at it a little bit, or
Sure.
whatever. And then I'm just trying to figure out what can fit where, you know.
Yeah.
But
yeah. Most of the components, most of the Victron components will actually connect to this.
through that, yeah, communicate.
Yep, and then they'll communicate with each other and to this main screen where he'll be able to monitor everything that's happening in the system and control the inverter, you know, switch that on and off or adjust the current limit, stuff like that. So we're gonna use this here.
Okay.
This is the larger one, and in a minute we can hop up on the roof and I can show you how we've arranged the panels.
Okay.
But yeah, we've got 2 series strings coming down here, terminating in each of these charge controllers. So this is a Lynx Distributor.
Yep.
And the batteries are going to come in to this Lynx Distributor, and this is where we tie them into parallel. Right, this is the same you see online how batteries are in strings, kind of like that.
Yep.
Well, so those batteries are in parallel. We're going to do the same thing, but we're just going to utilize a bus bar.
Okay.
And each string, each battery will be fused. So we'll have a fuse on 2 batteries coming in here. The other 2 slots will be empty.
Yep.
He can add to those later if he wants. And then that comes to the Lynx Shunt. This has a main fuse in it. And it's got the shunt, which is going to be
that's going to be communicating with your
computer. Yeah, that's going to be monitoring everything that comes into the batteries and everything that goes out of them.
Yeah.
This is where all of the main DC distribution is going to happen. And when I say main DC, you've got main sources like inverter charger, the MPPTs, the DC to DC charger for alternator charging.
Yeah.
These are the main DC components. And then you've got all of your other DC circuits like your lights, your refrigerator, your water pump, and those are going to come from your fuse panel. Right? So another main DC line that's going to be in this distribution
will go to the fuse panel.
Exactly.
Yeah.
Yep.
To the DC side of the fuse panel.
To the DC side.
And then the inverter will send power to the 120 side of the so right?
I'll show you what I did with the inverter here. So the way this was set up originally, this orange wire fed in to this main distribution panel. This is the main AC breaker box, right?
Okay.
So this, on your main 30 amp breaker, this is a 30 amp coach, this is what's feeding it.
Okay.
And he's got a generator, right? So there's a transfer switch somewhere down the line. Shore power comes in to one side of the transfer switch, generator comes into the other, and depending on which one's active, there's one main output, which is this line.
Okay.
To the main
to the fuse panel.
AC, the breaker box, the distribution panel there. So all we do is we take that out of the distribution panel, we put it on the AC input of the Multiplus, and then we run our new line from the AC out to the exact place that was. So
you're just putting this in line with it then?
Exactly.
You're like
exactly. Yep.
Cut it in.
Yep.
Okay. What is that? The Orion?
Yeah. So this takes 24 volts. Our battery bank's a 24 volt bank, and it converts that down to 12 volts.
Okay.
So we can power all of our lights. You know, this coach is equipped with 12 volt appliances like most RVs.
Right.
And we've got to bring 12 volts into this DC fuse panel, and we do that with the Orion.
Why didn't they choose for a 12 volt system? What would be the advantages to go to 24?
Some of the biggest advantages, you can cut down on cable size.
Okay.
So you can save some money on the amount of cable as well as weight, you know, because those larger cables, those can add up quick. And you know, another reason that you might choose 24 volt is you also get more bang for your buck when it comes to the MPPTs. So if you look online, each one of these has a data sheet. And if you look at the data sheet, it'll tell you what that charge controller is rated for with a 12 volt battery bank, with a 24 volt battery bank, all the way to 48.
Yeah.
And you'll notice that we'll use the 130 as an example because I've memorized that one.
That one.
Yeah, so that's rated for 440 watts at 12 volts.
Okay.
Right, and so if you've got a 24 volt battery bank, that same charge controller is now rated for 880 watts.
Wow.
So if you
That's a big increase.
Yeah, double.
Yeah.
And it continues to do so as you go up in voltage with your battery.
So you're pulling more power from the panels, is what you're saying. Is that what it is?
It allows more. It allows this controller to be able to accept more power because the current has doubled.
Okay.
Right, because this is, or I'm sorry, not the current, the voltage.
Voltage, yeah.
It allows the charge controller to accept more power because the voltage has doubled, and that you know, watts, all watts is volts times amps.
Amps, yeah.
And so if you've got the same amount of amps, but you've got twice as many volts over here, then you can bring in that much more power.
Right, right.
So those are a couple reasons to get 24 volt. And one more is that you can actually charge those batteries a little bit faster, especially if you're using like a secondary alternator or a dedicated alternator to charge those batteries.
Does this vehicle have a secondary alternator?
It doesn't,
okay.
no. But this model, you know, the Chevy E, I think this is an E450. There's a couple companies out there that make brackets for
aftermarket ones.
Yeah, exactly. And you know, it just bolts on. You get a larger belt, and if you utilize a 24 volt alternator, it can actually send more current into your battery bank, you know, at a faster rate. This Orion is a DC to DC converter.
Okay.
Right now, the DC to DC charger, that's typically used for alternator charging.
Yeah. Bring it from the alternator and put it back in the battery.
Exactly. Yeah. Yep.
I'm editing videos every day. So I want to find like a hostel or something to go to, and I'm like, if the pandemic's closing places down, you know, if there's hotels with different sorts of policies and stuff like that, that's going to be just difficult for me to even do what I want to do.
Yeah.
So I was thinking with the van, I can actually turn this into a mobile podcasting video studio and platform to travel and live in as well. It's just basically
already insulated
open
for you, huh?
Yeah, a lot of it.
Nice.
But I'm planning to do a lot to it. I want to take out all the windows. I mean, take out the blanks here and put in windows all the way around. Right. Basically what I want to do is like if you wanted to do, if I saw you and you're like, you had an awesome story to tell, which I'm sure you do, everybody does. I'd pick you up and be like, show me around your neighborhood and take me somewhere beautiful.
Yeah.
Like in your community. Because I don't want to do it at a like Costco parking lot or something.
Sure.
You know? And then I would take you around, you tell me about your place. I do a vlog about where you live. And then we go to like here would be beautiful, you know?
Yeah.
And then I would take the table. Well, this would be a table.
Oh, look at that.
And then this is a J-shaped interview area. So this is the kitchen. This is my spot here. Then there would be an entertainment center there with a big LED screen. And my guests would be here. And you know, like the Joe Rogan podcast?
Sure.
You know, I'd have a table. That table would be on a lagoon mount or something.
Yeah.
And then I would have really, really high-end microphones that would be to my guests and me, and then I would just be communicating with them.
You know, you throw an AC in this, it's going to eat up room for solar because you're probably not going to want to give up your fan, right? Or are you just going to have an AC?
I was going to have the AC where the fan is.
No fans.
Yeah, because it kind of works as a fan, doesn't it?
Are you going to do a second alternator?
That's why I was talking to you. I mean, that might be an interesting thing to look at.
I think that would be, if you want to run an AC, anytime anyone is in a van and they want to run an AC, I typically always recommend getting a secondary alternator. Yeah.
What's the benefit to running that as opposed to having your standard alternator running it?
Most vans with the standard alternator, you know, you can get with, you know, most newer vans that have a higher output alternator, you can get around 60 amps to 100 amps, right?
Yeah.
And that's going to be at 12 volts, right? So if we go back to our formula, and we say 100 amps at 12 volts, right? Let's just keep it simple. Then that would be approximately 1,200 watts per hour, right? Now, if you go with a 24 volt battery bank, and you've got a secondary dedicated 24 volt alternator that's at like 150 amps, you know, that's over 3,000. Yeah. And so, and that's in the same amount of time, right? In 1 hour, instead of using 100 amps off of your single alternator, that'd be like pushing it. Like you'd be risking burning that thing out a lot sooner than it would
ordinarily.
Exactly. So, you know, typically I recommend 30 to 60 amps coming off of the standard alternator. And that's like, you know, 300, that's like 720 watts. You know, so the difference is a secondary alternator, you got 24 times 150, you know, let's call it 3,000 plus, compared to 760 watts.
Yeah, it's night and day almost.
Exactly. Yeah. And people use these secondary alternators, they call them under the hood generators. You know, because it comes standard on some newer RVs.
Yeah.
in camper vans and stuff like that. So especially if you're wanting to run an AC and you don't really want to worry too much about, you know, having that secondary alternator, if you need to, you can fire it up for an hour.
Yeah.
You know, just let it run for an hour. And
Yeah.
Because you know, those secondary alternators, they've got an external regulator that is sensing the temperature of that alternator. So if it heats up, you know, it'll tell it to cool down. It'll tell it to chill out. If, you know, the batteries are totally charged, that external regulator will also just tell the alternator to
just run it out.
Just hang out. You know, you don't really got to produce anything right now.
Yeah.
Cool off.
Yeah. Okay. I've sort of told you a little bit about my story, right?
Yeah.
I want to be off grid. I want to have. I want to be able to pull power to charge a air conditioning system. I don't want to be running the engine all the time, so I'm going to want some capacity. But that doesn't have anything to do with Victron, right? Victron's more about management of the capacity, right?
Yeah.
So I'm going to have a lot of electronics, always charging. But I'd like to have a microwave oven. I'm the kind of guy that just pops something in, you know?
Yeah.
And a refrigerator and appliances I'm not going too crazy on. I just want to be able to have an amazing studio to edit, and I'll have those sorts of electronics. Mm-hmm. But I think basically, I mean, is it true? Are you going AC or not? I mean, that's pretty much the question, right?
That's the biggest.
That's the biggest thing.
That's
right?
the biggest thing.
Yeah,
to decide whether or not, you know, like what kind of bank you should have.
Right.
You know, like and with an AC, you deck out this roof with as much solar as you can possibly fit.
Right.
You have a secondary alternator. You know, if you don't really want to think about it.
What do you mean? What do you mean? Don't want to think about it?
Like if you run into a few cloudy days.
Yeah.
Or
okay.
If you're not driving much and so the alternator's not working at all to charge those batteries, not working much to charge them. You know, like if you want to set yourself up to not be like stressed about like, can I run the AC? Because maybe you're not going to need to run it very often. Maybe you're not going to be in Florida, you know,
blistering
too frequently.
Yeah.
In the summertime, like, you know, 400 amp hours at 24 volts, like what we've got in there. You charge whatever you want. You could run that AC pretty much anytime. You know, not really have to worry about it much. I mean, if you're running it all night. In the morning, your batteries might be pretty close. Yeah. But then again, you're using a 12-volt AC that's going to be more efficient, right? And so I'd want to see the model of the AC, the model of, you know, that's a 12-volt fridge. Obviously, that's super efficient. Yep. But, you know, those things would allow me to get like a really good idea and give you a really good number in terms of what you should go for to make sure that you stay charged. Yep.
I was thinking even getting a thermal curtain and taking it right about here.
It's a great idea.
You know, isolate, because I'm just going to sit here and work. The smaller the area, right over the vents. Yeah. I don't give a shit about cooling all of that stuff. Yeah. Forget about it. I just want to make sure that because I'm going to be editing a lot. Can I help you and then learn while you put your thing together, or?
Honestly, right now it's like I'm at the point where I'm about to start wiring stuff together. And that's kind of a one-man deal, you know. I'm happy to show you sort of the process, talk through it. And so when it comes time for you to do your wiring, you know, if you haven't had much exposure to that stuff, or if it would be helpful to learn it, I'm happy to walk you through some of that.
Sure. You ever seen anybody do a podcasting studio in the back of their van?
I've heard of a couple of them. Seems like a great idea, man. Being able to travel and let's climb the ladder. I'll show you the solar on the roof.
Okay.
Let me just get up a little bit before you shot.
Okay.
Watch your step.
Yeah. So you put these up?
I did.
Okay. So he didn't have any solar before you?
None.
Before you?
Nope.
1,400 watts, that's a lot, eh?
Yeah, it's a decent amount.
What's the biggest system you ever set up?
The largest system that I designed and helped someone through was 4,500 watts on a schoolie.
Wow.
Yeah. It's about as much solar as you can get on a moving vehicle, I think. 4,500 watts, he really decked it out.
Wow.
So we did we did 2 series strings.
Okay.
Up here. So these 4 panels are in series.
1, 2, 3, 4.
1, 2, 3, 4.
Okay.
Yep, these 4 are in series.
Okay.
And those 3 are in series.
Okay.
Remember, we got 2 charge controllers down there.
Right.
And so these 4 are running to the larger charge controller.
And this is to the 30, right?
And these 3 are running to the 30.
Okay.
Yep.
And where are they going down? You said that it was going down right. Oh, this is the vent, huh?
That's the vent, yeah.
That's kind of convenient, huh?
It is.
Yeah.
Right.
Yeah. Cool, man. All right. All right.
This is where pretty much everything is going to sit, right? We've got the Lynx. I'm about to mount this to the wall.
Okay. That's all going to be here, right?
Yeah, that's all going to be right there. And he might build a cover to go over it, or he might leave it exposed. You know, he likes the look of it, so he said that to leave it like this for now, and he'll kind of decide how he wants to go about, whether he's going to build like his own little chase cover for it, or leave it out.
Yeah.
But yeah, we're going to mount this, and then it's game time. Then we're going to start you know, wiring everything else, because everything comes to this, right? Like the Lynx is
that's the first step. Sort of.
Well,
like,
yeah,
right?
I mean, that's where all the wires are going to meet. So having this mounted and in place is going to be really beneficial, because when we're running our wire from each component, we'll have this in place, and we don't have to really guess. You know, we can like see exactly, we can get the bend and know exactly how much wire we need, because otherwise we'd be guessing, probably end up wasting wire. Worst case, you cut it too short, you know, and then then you got to run it again, or. So yeah, mount the Lynx, and then start working on each piece in this box. We're going to have 6 or 7 different components in here that we're going to need to run wire from them to our Lynx. Lynx, because it links together.
Yeah.
And so we've got a Lynx Distributor here, the same as what we've got over here. This is just the cover. And in the middle here is the Lynx Shunt.
Okay.
And so this has a main A&L fuse that you'll put in here. That'll be one of the main protections of your system.
If something overloads, it'll pop that first.
If it goes over, yep, exactly. It'll pop that one first. And then, well, you know, the way this is set up in this case, the each battery string coming into this Lynx Distributor has its own fuse.
So there's actually just redundancy all over.
Yeah, lots of redundancy, and we like it that way, you know. Like, better be safe, you know. Take a little bit of extra time, and we were going to use the Lynx Shunt regardless whether it had this fuse or not. It just does. It comes with it, so that's an added bonus.
Yeah.
One of the advantages of the Lynx Shunt, you know, is that it is part of this Lynx system. Comes right onto the distribution block like that, so it's a little bit less wiring. It really depends on, you know, kind of your preference and what you want to do there, but there are quite a few different options for battery monitoring, because at the end of the day, that's what this is. This Lynx Shunt, this is battery monitoring.
Yeah.
It's measuring everything that goes into the batteries and everything that comes out of the batteries, so that you can get that percentage, that state of charge, and know exactly where your batteries are at. Okay. And as you run things, you know, say you run your AC or something, you can look at how many amps are coming out of your batteries when you've got that flipped on, you know. So it's a cool way to see exactly how much energy different appliances use.
Right.
I'm taking a minute to kind of chill.
Decompress?
Yeah, exactly. It's been a long day.
But you finished.
I did.
Yeah.
Feeling good.
Yeah.
I'll grab some water.
Oh boy. I got a cold water. Do you want a cold water?
Well, yeah.
In my fridge I got a cold water.